Welcome to this lesson on linear equations in two variables. Today, we'll learn what these equations are, how to graph them, and how to solve real-world problems using them. Let's start by understanding what a linear equation in two variables is. A linear equation in two variables takes the form ax plus by equals c, where a, b, and c are constants and a and b are not both zero. Here are some examples of linear equations in two variables. Linear equations can be written in different forms. Let's look at the three common forms. The standard form, ax plus by equals c, where a, b, and c are constants. The slope-intercept form, y equals mx plus b, where m represents the slope and b is the y-intercept. The point-slope form, y minus y1 equals m times x minus x1, where m is the slope and x1, y1 is a point on the line. Now, let's see how to graph a linear equation in two variables. To graph a linear equation, we need to find at least 2 points that satisfy the equation. Let's graph the equation y equals 2x minus 1. We'll create a table of values by choosing some x values and calculating the corresponding y values. When x equals 0, y equals negative 1. When x equals 1, y equals 1. When x equals 2, y equals 3. Now, we plot these points on the coordinate plane. Finally, we draw a straight line through these points, and that's our graph. Let's explore the slope-intercept form in more detail. In the equation y equals mx plus b, m represents the slope, which measures the steepness of the line. The slope is calculated as the ratio of the change in y to the change in x. A positive slope means the line goes up from left to right. A negative slope means the line goes down from left to right. A zero slope means the line is horizontal. An undefined slope, when it is 0, means the line is vertical. The y-intercept, represented by b, is the point where the line crosses the y-axis. Let's look at some examples with different slopes and y-intercepts. Linear equations in two variables are used extensively in real-world scenarios. Let's look at some practical applications. For example, in a business context, the total cost C of producing X items can be represented by the equation C equals mx plus b, where m is the variable cost per item and b is the fixed cost. Let's say it costs a company $5 to produce each widget, and they have a fixed monthly cost of $1,000. Their cost function would be C equals 5x plus 1,000. Here's the graph of this cost function. From this graph, we can see that even if they produce 0 widgets, they still incur the fixed cost of $1,000. And for each additional widget they produce, the total cost increases by $5. Another common application is in distance-time problems. The relationship between distance and time for an object moving at constant speed can be represented by the equation d equals vt, where d is the distance traveled, v is the velocity or speed, and t is the time. Let's say a car travels at a constant speed of 60 miles per hour. The distance function would be d equals 60t, where d is in miles and t is in hours. Here's the graph of this distance function. The slope of this line is 60, which represents the car's speed. After 1 hour, the car has traveled 60 miles. After 2 hours, it has traveled 120 miles, and so on. Now, let's summarize what we've learned about linear equations in two variables. Linear equations in two variables take the form ax plus by equals c. They can be written in different forms, including standard, slope-intercept, and point-slope form. The slope-intercept form, y equals mx plus b, is particularly useful because it directly gives us the slope m and the y-intercept b. These equations have numerous real-world applications, including cost functions, distance-time relationships, and many more. Thank you for watching. I hope you now have a better understanding of linear equations in two variables and how they can be used to model various real-world scenarios.